Oh, hello? Yes. Okay, so welcome. So it's a bit unfortunate not everyone's here yet because this is kind of front-loaded, so if you miss the tech part, then it's going to go into the rest of it. But hopefully you can fill people who are late in. So I'm Oliver. I'm a PhD student at the University of York, and this work was done in collaboration with another PhD student, Nathan, who's in the audience, and a bunch of our supervisors. So the most obvious question for me, reading the title, is what actually are crypto games? So can I just get a quick show of hands? Who knows roughly what a cryptocurrency is? Okay, cool. And who knows how they work? Okay, cool. Okay, so what are crypto games? So if I kind of frame this in terms of the traditional game design kind of architecture. So you have typically a client-server model. So this is the game state stored on a server which is managed by the developer. So this is kind of an abstraction. So if you're using, for example, something like Amazon Web Services or servers, then the server is actually kind of a cloud, so it is in itself a network. But the emphasis with this kind of comparison is that it's centrally managed. So this really contrasts to the kind of crypto games architecture in that instead of a client-server model, we have this kind of client-network model, where instead of the game state being stored on a single server or kind of the cloud, it's instead stored atop a cryptocurrency network, which is a network of computers which store a synchronized distributed ledger. So if that doesn't mean anything to you, then that's fine. The main takeaway from this is that by decentralizing the storage of the game state, you actually incur a cost, or more accurately, the client incurs some sort of cost. So in a game like, just off the top of my head, something like World of Warcraft, Blizzard will probably be paying someone to host their servers, or they'll be hosting them themselves. And so the client does end up paying a monthly subscription, but they're not necessarily paying for the server directly. Whereas in crypto games, the client, that kind of cost of executing commands is actually transferred usually to the client. Another important point about this is that this is not kind of an A-B scenario here. This is like a spectrum. So it's kind of on the typical model on the left, you have the entire game state stored on the developer's server, and on the networked one on the right, you have part or all of the game state on the server. So it's kind of like you have this kind of spectrum of how distributed you want the game to be. So why should we care, right? Why is this a thing? This is hopefully the next obvious question. So it's a different premise for gaming. And so by storing the game state atop a cryptocurrency network, the tokens that you choose to hold in that game state enjoy all of the kind of security benefits of the cryptocurrency. So this is things like censorship resistance, resistance to tampering, and things like that. So there's that kind of hidden benefit, which is kind of also part of why you would develop a game like this. So there's a growing player base and trading volume. So a big emphasis of these games is that trading of virtual items between games and between players seems to be kind of a useful and interesting part of their design. And finally, so because they use cryptocurrency, it's a new payment mechanism, or more accurately, it's a new way of integrating payment into the design of these games. So as the slide before, because the game state is held on a network, it means to change it, you have to initiate a transaction, and then that transaction obviously costs something. So it's not like you can just transfer the game state from a single server onto a network for free, free lunch, great, no one has to pay for anything. Someone actually has to foot that cost. And so that's kind of something to keep in mind. So how does this actually manifest in terms of games that exist now? So we'll take two case studies. So the first one is Gods Unchained. So has anyone played Hearthstone? Okay, cool. So Hearthstone, Magic the Gathering, things like that, they're kind of competitive card games which emphasize deck building, so more powerful cards, things like that, and then this kind of turn-based combat element. So in the case of Gods Unchained, the cards themselves are stored atop the Ethereum network. So Ethereum is a type of cryptocurrency, one of hundreds. It just so happens that it's the largest one by market capitalization that explicitly has the ability to implement the smart contracts, which is this kind of underlying technical detail, which you find out more about in the paper. But it has that capacity. And so these are two examples of cards. And so in terms of art style and things and function, they're very similar to Hearthstone cards, Magic the Gathering cards, that type of thing. And then second example is CryptoKitties. So this you may have heard in the news. So this was really, really popular 2017, 2018. And so the whole thing is that you're collecting and breeding these digital kittens which have different attributes. And so the gameplay revolves around literally getting two kittens, and then you breed them through a web interface, and then there's this kind of element of chance where you're not sure which of the parents' attributes will be transferred to the child. And so on. And so this also uses the Ethereum network. So all of the studies all of the games, that we sampled sit atop the Ethereum network, and they vary in terms of how decentralized they are. So this study, at least in this point, is just a single sample of a single type of cryptocurrency network. There's hundreds of different variations, but this is really just to kind of start the discussion about it. So what now? So we know in very high-level terms there's something different with the storage, and it's all a bit technical, and they have this kind of different properties. So the client network model introduces costs. This is kind of inevitable. Costs will be kind of realized in a number of different ways depending on the type of cryptocurrency you're using, but generally they introduce costs. And chance-based mechanics exist. So kind of piggybacking on Trini's talk, uncertainty is kind of fun and interesting, and it's kind of a really useful part of game design. And so this cost-chance combination, hopefully you can see there's something untoward here. So let's apply some definitions. And this is kind of a realization that my co-author Nathan and I had in our lab when we were talking about it. We were like, this looks a little bit familiar to some of my other work. So which definition did we apply? So we took 4 criteria from the gambling literature. So more accurately, the gambling studies literature, which is a branch of psychology. So this is, from a psychological perspective, which behaviors should be of interest in terms of how they're different to just normal types of risk, right? So what separates one activity from another in terms of its relation to gambling? And 2 criteria from the UK Gambling Act. So I know we're in Spain right now, so this study is specific to the UK. So we took the psychological, a 4-point criteria from the psychological literature, a 2-point criteria from the legal kind of literature, and we essentially combined them because one of the legal ones actually turned out to be pretty much identical to one of the psychological ones. So it made sense that we could make this kind of combined definition so that it's useful pretty much for everyone. Because ultimately, if you're looking at an activity and it meets the psychological definition of gambling but doesn't meet the legal definition of gambling, then you have this kind of weird difference, like should we be interested in it? Should regulators be interested in it? And so it makes a little bit more sense to combine them. So the key finding was that typical gameplay in all of the sampled games met our combined definition. So typical gameplay here, we took to mean the gameplay that was advertised in marketing material, in gameplay videos and things like that, and kind of the typical gameplay. So in summary, and kind of if you are more interested in this and more interested in the technical side of things as well, you will find in the paper a sample of popular crypto games on the Ethereum network in particular. You'll find a description of their mechanics and their prevalence. So because they exist atop a cryptocurrency network, that means that all of the user interactions, all of the transactions that they create are publicly observable, which means that from a research perspective, we can see literally everything that the users are doing for the game state, for the part of the game state that they're modifying, which sits atop the network. We then applied legal and psychological definitions of gambling and found that the entire sample met all of the definitional criteria. Again, this is just a small sample of crypto games just on one cryptocurrency, and this varies immensely. So to conclude, so we're here, so that's me in front of my favorite color, and Nathan is sat in the audience, and the paper is pinned on my Twitter, I think on Nathan's Twitter as well, and this entire paper wouldn't be possible without all of the co-authors as well. So that's Sebastian, Anders, James, and David, and there's all their contact information. Thank you.
Questions? Oh, questions. Starting over here. Oh, well, let's start over here and then we'll move on. Vera van der Abele, KU Leuven. Can you give any of the definitions, the criteria? Because I'm really curious now, but you haven't answered it.
Okay, so they're split, so they're obviously in the paper, but so the legal definitions is something like there is an element of chance which determines the exchange, and that the exchange is money or money's worth. So in other words, if I were to, I don't know, bet 3 bananas on a roulette wheel, then that wouldn't meet the legal definition, but if it was kind of 3 sterling in roulette wheel, then it would. And then so the psychological definition, off the top of my head, it's kind of along the vein of, is the exchange determined by chance? Is there some exchange of financial value? I think that's a little bit more broad, but we can merge those. Yeah.
Okay.
My question, answer typing electronic arts. My question was essentially that, but maybe we can elaborate a little more. Where did you get the psychological criteria from? Because there's a lot of disagreement in the literature on what gaming addiction is, or if it is. So was this the DSM-5, or was this the ICD-10? Or?
So the definitions themselves, they're originally based on Mark Griffith's 5-point criteria from his book in 1996, but they were since revised by Drummond and Sauer, so they refined it to, I believe, a 4-point criteria. I believe one was a 4-point, one was a 5-point, but then essentially Drummond and Sauer kind of skipped Mark Griffith's revision, so he actually revised it more recently, but they didn't pick that up, and so we kind of picked it up and drew influence from Drummond and Sauer as well.
Thanks. I just misspoke. It was gambling, not addiction, but that's what I meant. Yeah. Thanks.
Any more questions? I have a quick question.
Yeah.
So with a crypto network, you have a lot of different servers, and there's been a lot of talk about like how much energy that consumes. And just looking into the future, do you think that will have any influence on like the game development?
So ultimately because it's stored on the network, executing any code or getting that network to do anything becomes more expensive. And so the games that we looked at, so CryptoKitties as an example, the transaction cost associated with any game action, so like if you were to breed 2 kittens, I believe is around 10 cents. So with different network structures and sizes, that cost will vary. But ultimately there is some sort of cost in there, unless it's sponsored. So.